Okay, good morning. I am Anand Ramamurthy, a visiting faculty in Petroleum Engineering Department, and I am basically from the industry with a master's degree in UK. So for today's class, we are going to talk about well control in drilling operations. When we talk about drilling, it starts with exploration, drilling, production, and then enhanced recovery methods. So for today's talk, we are going to go towards the drilling, and in specific, we are going to talk about well control methods. So first, we need to know what well control is. Well control is nothing but when we are doing a drilling operation, any operation for that matter, the well should be in the driller's control or the operations team's control. If for any reason the well goes out of control, we have to bring it back to our control so that we can proceed with whatever operations we are planning to do. That is well control. Well control we can broadly classify into two parts. One is the principles and the procedures side, which is done at the office level or at the rig level, and the equipment side, which is 100% done at the rig side. In this topic, we are going to concentrate more about the principles and the procedures. That is more of a technical side. And if time permits, we will cover on the equipment side. So as I said, well control. Whenever during a drilling operation, if the well goes out of our control, it is our duty and our utmost importance to bring it back to our control. Before we start understanding about or talking about well control, we need to understand the basic physics behind well control. So we will go back a bit to understand the pressure terms, which are very much required, or you need to have a better understanding of the pressure terms. So what is pressure? So what we have studied in the school level and what we have studied in the first year or second year. So pressure is nothing but force applied on a unit area. Pressure is equal to force divided by area. Pressure P is equal to F divided by A. So what is force? Again, we get back to the basic physics. Force is nothing but anything which is moving you from the present state, or energy which is acting on you or any body which it makes or keeps it in motion. That's a force. When this force, when it acts on a unit area, the amount of force which is acting on this area is called pressure. So we need to understand or have a full knowledge about pressure. So force is the energy when it is acting on a particular area that becomes pressure. Okay. Now what are the different pressures we are going to see in drilling, specifically in petroleum engineering? First, we talk about hydrostatic pressure. Hydrostatic pressure is nothing but the force exerted by the fluid column because of the height. So the hydrostatic pressure is dependent on the density of the fluid, the gravitational force which is acting on the fluid, and the height of the liquid column. So hydrostatic pressure is nothing but rho GH. Rho is the density of the fluid, G is the acceleration due to gravity, and height is the height of the liquid column which is acting. This is the formula which is generally used. But for oil field terms, we remove G, which is the acceleration due to gravity, and we simplify the formula with numbers so that you can calculate the pressure, hydrostatic pressure in field units. So hydrostatic pressure is 0.052 into density of the fluid in pounds per gallon. So we start introducing the oil field units times H. H is the height, here we call it as depth. Since we're going to drill from the surface and we're going to go deeper, instead of height we call it as depth. And the unit for that is feet. And the pressure what we are going to get, we get in PSI. Pounds per square inch. Pounds per square inch is equal to 0.052 into density of the fluid in pounds per gallon times the depth of the well in feet. This is hydrostatic pressure. Then we talk about the reservoir. We are going to drill into a reservoir or a formation where we have to understand the characteristics of the formation or the reservoir rock. So we talk about pore pressure. Again, we express all the pressure terms in terms of PSI, pounds per square inch. Pounds is nothing but the pound force acting on area, unit area, square inch. Pressure is equal to force divided by area. That's pounds, pound force per square inch. So what is pore pressure? So we know the reservoir. The reservoir is made up of sand or any formation which contains oil or gas, which is basically hydrocarbons. So where is this hydrocarbons present? In the pore space, the void space which is present in the rock matrix. That is the pore space. So the fluids, for that matter, it can be oil, water or gas. Any fluid which is present in the pore space, which is exerting some pressure, some force on the rock matrix, that is pore pressure or formation pressure. So there are different terms for reservoir pressure. But basically, it is the pore pressure. The fluids present in the pore space which exerts a force on the available area, and that is pore pressure. This is only because of the fluids present in the pores, not because of the rock matrix. Then we talk about fracture pressure. So we talked about the void space and the fluids pressure is pore pressure. But now we are going to talk about the rock matrix, which is basically the formation or the earth. This earth or this formation during the sedimentation process, because of sediments which is going to go on top of it, one layer above, this gets compacted. And as it goes deeper and deeper, the compaction is more because of the weight of the overlying formation, which gets compacted and it becomes stronger and stronger, depending on the depth and depending on the environment where it is buried. So the strength of that particular formation at a particular depth, we term it as a fracture pressure. So fracture pressure is nothing but the pressure exerted by the external force, or the force which is exerted on that depth, on that particular rock matrix, which will crack the formation, which will break the formation. That is fracture pressure. So this fracture pressure is a component of the pressure what we apply from the surface plus the hydrostatic pressure caused by the fluids and the pore pressure. So this fracture pressure is very, very important for the reason to bring the well under our control. So we should not allow the formation to fracture. If we fracture the formation, we cause more damage. If we cause more damage, we don't lose control over the well. It interrupts the drilling process. It creates more of non-productive time. That means we try to do some operations to bring the well under our control. But these activities are of no use. We damage the formation, we create a problem, we solve the problem, bring the well back in control. Till we bring the well back in control, the time and money spent on the well is called non-productive time, which is basically waste of time and money. So when we plan for drilling a well, our intention or one of the objective is to keep the NPT or the non-productive time as low as possible. So this is the main objective in the drilling program. So the planning and design is always to reduce time and indirectly cost. So for that we need to know these things very, very clearly without any confusion so that we can proceed to well control. So hydrostatic pressure is exerted by the column of fluid. Pore pressure is the pressure exerted by the fluids present in the pores. Fracture pressure is the pressure till which the formation can withstand before it breaks. So these are the three pressure concepts we have to keep in mind. Now we will go back to drilling. So when we are drilling, we have to use drilling fluids which will exert a hydrostatic pressure. And that hydrostatic pressure should always be slightly more than the pore pressure, so that the formation fluids will not enter the wellbore. So our interest is to drill the well first. When we drill the well, this pressure should not affect us, should not stop our drilling process. So we need to control this pore pressure. So we use drilling fluids, and the main objective or one of the main objective of the drilling fluid is to give the required hydrostatic pressure to control the pore pressure. Next, the same hydrostatic pressure should not be high enough or it should not be more than the fracture pressure. When it goes more than the fracture pressure, the formation breaks. When the formation breaks, the fluid, what we maintain, the height what we are maintaining will reduce. The fluids, because of the fracture, will get into the formation. The hydrostatic pressure reduces, so we cannot control the pore pressure. The pore pressure is going to act on us. That is a well-controlled problem. So what is well control? Again, the pressure differences inside the wellbore causing problems, or in other words, the problems which are caused due to the pressure differences inside the wellbore between the hydrostatic pressure and the pore pressure. That problems we call it as well controlled problems. If it is any other problem out of this pressure differences, we call it as well problems. It may be because of the pipe which is getting stuck, or because of shales which are swelling, which will make you stop, or you will not be able to pull or push the pipe, or if the drill pipe or the drill string breaks, falls inside the wellbore, that becomes a drilling equipment problem. So here we talk about well control problems and the control methods. So any problem which is caused inside the wellbore because of the pressure differences between the hydrostatic pressure and the pore pressure. It's called well control problems. So when we talk about well control problems, two things: principles and procedures and the equipment which are used to control. Principle and procedures is paperwork. Equipment is work at the rig site, or the equipment physically used in controlling these problems, or bringing the well back in our control to proceed with drilling. So here we talk about the procedures, principles. So now we are going to go to the next level to understand about how these pressure differences is going to act on us and take us away from the drilling. First, if the hydrostatic pressure is more than the pore pressure, that is called overbalance condition. So if you consider a U-tube, we consider this as a hydrostatic pressure of the drilling fluids. This is pore pressure. Because of the drilling fluids, the hydrostatic pressure is more than the pore pressure. That is called overbalance. The well is in overbalance condition. The hydrostatic pressure controls the pore pressure, keeps a check on the pore pressure entering into the well. For any reason, this condition goes off and the pore pressure becomes more than the hydrostatic pressure. It's a reverse of overbalance. We call it as underbalance. So the main parameter is the hydrostatic pressure. If the hydrostatic pressure is high, it is overbalanced. If the hydrostatic pressure is less than the pore pressure, it is underbalanced. If it's an underbalanced condition, we start losing control over the well, and the well takes control of us. So the pore fluids starts coming inside the well bore, and it disturbs the well bore. Where we maintain the drilling fluids, we give hydrostatic pressure to control. If we lose this control, it is very difficult to proceed further with drilling. If you don't understand the situation and if we proceed with drilling, we aggravate the problem. So when we get into underbalance condition, if you are aware of it or if you are unaware of it, we have to make sure that we have the control. Even in underbalance conditions, the newer techniques, the advanced drilling techniques, we drill the well in underbalance conditions, but still we keep the control. We don't allow the formation to take control. Pressures, hydrostatic pressure, pore pressure, overbalance condition is where we do the drilling. If the well goes into underbalance condition, which means the pore pressure is more than the hydrostatic pressure, we have to stop drilling, do the well control procedures to make sure the hydrostatic pressure becomes more than the pore pressure. So we have controlled the well, confirm it is safe, and then we proceed with drilling. This is well control, and when we say well control procedures are done, what we can do. So now we will go to the next stage. We will go with the kicks. What is a kick? Why it happens? When it will happen? How we identify the kick? If we identify the kick, what is the procedure we have to follow? That is the well control procedure. And when we say a successful well control, or we have controlled the well, that means we have eliminated all the additional pressures from the well, taken out all the risks for further drilling, and we are safe to drill the well. That is successful well control operation. So we're going to talk only on this for the next hour. Okay. When we say kick and well control, so we have to know what a kick is. So we're going to look in detail about the kick, the anatomy of the kick, the definitions about the kick, when it will happen, if it happens, how we identify or how we detect it. If we don't identify it, we're going to proceed with drilling, we're going to cause more pressure differences. Then, the well control methods or the kick control methods. Well control, kick control, the same. Kick control, what are the methods of controlling the kick? Because it is not the same method which is used for every kick. Depending on the formation pressures, depending on the depth where we are, depending on the equipment we have, we decide which is the best method. So there is no trial and error here. We have to identify or detect it. Then we have to understand the situation, where we are at the moment. Then we have to select the best method and proceed with the control. There is no trial and error. If you do a mistake, it's going to be a catastrophe or it's going to be a blowout, which we will look in detail. So we are going to have a pictorial representation to show so that it gets in your mind a bit easier, so that you don't forget the basics. You don't forget at any point of time. This is the formation what we are going to drill at the surface. We are going to drill. Drilling is nothing but making a hole in the ground. As we go deeper and deeper, we make the formations which we have drilled are safe. It's not going to affect us in further drilling. So we run casings at every level as we go deeper and deeper. As we start drilling deeper and deeper, the hole size starts reducing. So it becomes like a telescope. We start with a larger diameter. Once we run a casing, the next drilling is going to be smaller size. Casing, next smaller size, and casing. So when we reach the target depth, or when we reach the reservoir, where we have the hydrocarbons, oil and gas, the hole size normally a preferred or a required size is 8.5 inch. So one of the objective of drilling is to end the well in an 8.5 inch section. 8.5 inch. So that we have more equipments to do all the logging, all the testing, and we can produce in a better way. We have options of deepening the well if required in the later stage. So when we drill, this is the bore pressure. This is the hydrostatic pressure what we maintain. As long as they are same, balanced condition, or the hydrostatic pressure is more, overbalanced condition, the formation is going to sleep. It's going to sleep. It's not going to disturb us. If we wake up the formation, that's going to add on us. So the deeper you go, the formation pressure is more. So we have to maintain the hydrostatic pressure balanced or overbalanced to keep it at rest. So the formation pressure at every depth is balanced or slightly overbalanced by the hydrostatic pressure caused by the drilling fluids what we do. So we circulate drilling fluid. So we have to decide on the right density. So the density which is given in ppg, pounds per gallon, we have to decide or formulate the density for a particular depth so that we always keep control of the pore pressure. Okay? So when we are drilling, we have no balance condition, no problem. But for any reason, because of any problems, if this pressure becomes less than the formation pressure or the pore pressure, we go into a underbalanced condition where we wake up the giant and it's going to act on us. So the pressure, pore pressure, when it acts on us or when it tries to get inside the wellbore, that means wellbore is a hole which we have drilled. If the pore pressure starts entering into the wellbore, that is a kick. A kick is an unwanted, uninvited guest inside the wellbore. The formation fluid. For that matter, it can be oil, water, or gas. Any formation fluid which is entering into the wellbore in an underbalanced condition is called a kick. So when the kick enters into the wellbore, a new person entering into the wellbore will stop us from drilling again. So you have to identify the kick. The situation has happened and control. The quicker you identify the kick and the quicker you control the well, the non-productive time is less. It's like how you get an infection in your body. Initially the body might be resisting, you may not know. But sometimes when the bacteria or virus which gets inside our body starts taking control, we identify it. You get fever, joint pains, headache, vomits. So you get to the doctor. What does the doctor do? He starts identifying what is the cause of that problem. Formation fluid entering into the wellbore is a cause, but we have to identify the reason why it has come. Because it is under balanced condition. Why this underbalanced condition has come? The underbalanced condition can be caused by various reasons. So you need to identify the correct reason why the hydrostatic pressure has reduced, and you have to correct it. Once it is corrected, we put the joint in rest and push it back into the formation. So when you get a kick, when you get an indication of a kick, it's like a slight fever. There is no need to panic, no need to press the panic button or shout or make everybody aware that there is a kick. A kick is a slight infection which can be controlled much easily if it is identified in time. So when you get a kick, when you get an indication, when you confirm it is a kick, you start taking well control measures. Circulate the kick out of the well, take control of the well, proceed with it. So at this stage, the kick is easily controlled, so there is no need to hit the panic button. But it is okay to worry a little. It's not that we are completely out of danger. That is the starting point. If we act rightly at the starting point, we can control the kick. Now, what if we don't control the kick? Or what if we have not identified the kick in time? The kick is not going to stay there. Once it enters the wellbore, it's going to start coming out of the well. It's going to move up. And when that formation fluid or the unwanted influx, unwanted entry of formation fluid, when it reaches the surface, it is uncontrollable because it has grown bigger in size. When it becomes bigger in size and when it reaches the surface, that is called blowout. So blowout is a catastrophic situation. Because we are unable to control it. It takes much longer time and advanced methods to control when the kick starts moving up. When the kick happens, if you close the well and start the well control methods, it is easier to eliminate the kick. We don't allow further entry. It's like 2-3 people entering in our house. There are 5 people. We can control them easily. But if you are not taking enough steps in time, more people coming inside, they outnumber you. They become more in number and they control you. That is blowout. If somebody says there is a kick, that's within our control. But if it is a blowout, That's a big damage. And the worst case is what we have seen in the Macado. We lose the rig, we lose people, we lose the environment. That is catastrophic. It can be of any level. A blowout is a blowout. Sometimes land rigs, if we completely burn down the rig, that's it. It is not only the well which is gone, it is the complete rig which is gone. Still, you have to control this. You have to bring another rig, you have to still control it and seal it. So that's why it is always better to keep a watch on the well pressures. The pressure differences, when they are small, it is easy to control. Don't allow it to come to the surface and cause a big damage. So, undetected until too late, heat fluids has unloaded the well bore. That means, once a formation fluid gets inside, it will start replacing the drilling fluids. If the drilling fluids are completely replaced, the hydrostatic pressure starts reducing. When the hydrostatic pressure starts reducing, the underbalance condition becomes larger. The bore pressure takes a complete control and becomes a blowout. So within the tools and techniques available today, it should never happen. That means we have an idea what underbalance condition is. We have methods or equipment, tools to identify the kick. We have a good knowledge about kick control methods. So this should not happen. This should be within our control. But still, even in day-to-day drilling operations, we see blowouts. We see equipment getting damaged, environment getting damaged, and more than that, loss of life. This should not happen. If this should not happen, we need to have a better control. More than that, we have to be very, very vigilant at the rig side. Any small pressure differences, stop drilling. Check if it is a kick. If it is not a kick, confirm and proceed with drilling. But if it is a kick, we have to start the well control methods immediately. So, when there is a wrong indication, don't take it lightly. It has to be confirmed whether it is a real alarm or a false alarm. If it is a false alarm, it is well and good. You proceed with drilling. Every time you get a false alarm, every time you stop drilling and confirming. It is not that you say that no, that is a faulty switch. Because of that, it is an alarm. If it is a faulty switch, stop drilling, replace the switch, and then proceed with drilling. Okay? Thank you.